It's going live now. Hey, Kaylee. Now, when you say, do I do research in chemistry, like, what do you mean? You mean for the school or just personally? Okay, so as you guys can see, I have it muted so that I am not talking, so it doesn't have an echo back. So as you guys can see, we are live. And now I'm going to share my screen so that, yes. Okay, and let me make sure everything else is good to go over here on these YouTube streets. Okay. No, I don't do it for the school. No, I do not. So yeah, there we are right there. Okay, so again, I'm not gonna log out of that. I'm just gonna close the screen so I don't have any feedback. Okay, so there we go. There we go. Thank you guys so much for bearing with me. Hey, Slay Queen Pearl. I like your name. Hey, Van. Y'all have some unique names, whether they're burner accounts or unique names. I love it. Hey, Alyssa or Elisa. All right, so let's go ahead and get started. Today, we're going to pick up where we left off at, and this was dealing with molecular geometry, where you have to draw these bonds out. So just to kind of recap and show you guys what we were talking about, let's say that your professors gave you a compound or a formula, and they wanted you to draw the picture out. Do you know what a double bond is? Do you know what a single bond is? So these are the things that we kind of went over yesterday, and we drew them out. And when we drew them out, we just looked at how to put all these dots around them, because this is what molecular geometry is. And so I showed the students how they're able to figure this out without causing a headache. Now, here's the thing though. When you draw these pictures out, you also have to know the shapes of them. And so I provided students with just a little snippet of an introduction to that part to know how the shapes are drawn and how to determine, like, is this trigonal pyramidal? Is this tetrahedral? All of that. So we're going to actually pick that up again. Yes, Richard, I will do NO2. Yes, that is a resonance structure. And remind me of that. We'll get into that as well today. Resonance structures are just simply the orientation of in which your oxygen bond tends to move around multiple different ways. Okay. So, yes, I got you covered on that. I sure do. Thank you so much for bringing that question up. And I will be sure to go over that one too. Okay. So, to start you guys off, I just want to say, if you are in a chemistry class, your professors may give you all examples where they're going to give you the name. So, for instance, if I told you to draw out the structure for, let's say, carbon dioxide, okay? Your professor may give you the name carbon dioxide, and as a challenge, if you're in honors chemistry or you just have that professor that's about that life in terms of making you all work for it, they may not give you the formula CO2. They may tell you, hey, you need to draw it out. Okay. So lay 777, I actually have multiple videos on my YouTube channel and also on my TikTok channel. So if you want to know how to do balancing chemical equations, that's where I have those on. Okay. Hey, Zaria. Hey, Jackie. Hey, Evelyn. Hey, H. Hey, Ashley. You're welcome. You're welcome. Now, if you do have questions outside of what we're doing, for the first 45 minutes when I'm teaching the material, I go over these questions that you guys may have. And then if you have anything that's outside of what we typically have a lesson on, I'll save those for like the latter part of the session. Okay. So those of you all that are just coming up, thank you, Phi Black Pantheria. Good job, Lucy. Thank you so much for sharing my YouTube channel as well. I appreciate that. And Lucy, that's fantastic to hear that you got an 80 on your AP chemistry class test. Yes, that's fantastic. You know, whenever I do these live chemistry tutorials, I try to make sure that I'm targeting the questions that I may be going over with my students currently, as well as what you guys are going through in your class. So if there's any point in time that you need me to go over anything, join the line. I've got videos lined up. I'm just in an editing process, but make sure that you guys put comments in one of my latest videos so that you're able to get that question answered, you know, as we come through. Okay. So let's go ahead and get started. As I mentioned before, you may have a chemistry professor that may not give you the actual formula. They may say, draw it out based on the name. So you're having to work an extra step. So as you guys can see here, I have CO2. We've already actually did that, but I just want to kind of point out to you that you may have a teacher who may not want you all, who may not give you all the extra stuff, and you have to do the extra work. So let me show you what I mean by that, okay? So for instance, see how in parentheses, let me zoom in so y'all can see this right here. You see how in parentheses where it says draw out ammonia. Okay, they put ammonia, NH3. Well, here's the thing. You may have a teacher who may not have that listed. They may cover that up and they'll just tell you to draw it out. So if you're not able to draw it out, you'll be in trouble with that, simply because some teachers are on that extra oomph well, they want you to do a little extra work, okay? So I'm going to go ahead and show you guys some examples today. Some we may have already done, but I will show you guys some other ones, okay? Brooke said, all that BS. Yeah, yes. And yes, that's right. FI Black Pantheria. You're right. The understanding of ammonia versus ammonium, because there is a difference between the two. Yes, yes, yes. Okay, so pick a number, guys. Somebody put the first person that puts a number down, that's the one that I'm going to do. Whether I did it yesterday or not, I'm going to do it, and then I'm going to show you guys how to determine the shape. So put a number down, and the first person that I see put a number, I'm going to do that. Okay, someone said, Alexis said 5. All right, CH4. This is the one that we're going to do. Richard said 6. I'm going to do that one next, okay? So we're going to do 5 and 6, and then Ash said 3. So let me put a check mark by those so I will remember which ones we're doing. Okay, 3, 5, and 6. Okay, Giselle said, is that methane? Yes, it is. The one that is CH4, yes, that is methane. Yes, yes, yes. So we're going to do that one first. Number 5, okay? Number 5. So you've got CH4. The easiest thing I can tell you that when you are doing these is to do the math. Now, when I say the math, we're talking about basic math. All you have to do is just separate the element, okay? Separate the compound into individual elements. So you've got 1 carbon, but you've got 4 hydrogens. So now what you're going to do is you're going to multiply them each by their valence electron value. On your periodic table, as a recap, every element in group 1 has 1 valence electron. All the elements in group 2 have 2 valence electrons. We skip groups 3 through 12, and then we mosey on over to groups 13 through 18, where you drop the 1, and that tells you what the valence electrons are, okay? As an example. And again, because I know some of you guys are visual learners, let me do this. Let me pull that here. And I'm just going to go ahead and insert a periodic table so you guys can see what I'm saying visually, okay? Because I know everyone doesn't always hear or see what they should hear, okay? So let me go ahead and pull up a periodic table. So I'm just going to Google one. Here, there we go. This is the one I always use. Okay, so again, to recap. Okay, Maddie asked a very good question. How do you know the valence electrons for those that are in that group? Well, you know what? The ironic thing about it is we tend to not do the periodic table or the formulas for those that are in groups 3 through 12. However, if we did do those, we would tell you what they are. Very good question. Very good question. But we tend to skip those. Part of the reason is because those are your transition metals and they have multiple charges. And because they're transition metals with multiple charges, multiple issues, okay? They have multiple issues. So again, all the elements in group 1 have one valence electron, okay? So let me put that here. I'm going to actually put that right there. One valence electron. All the elements in group 2 have two valence electrons. We skip 3 through 12, and then we mosey on over to groups 13 through 18, where you drop the 1, and so you get 3 valence electrons for group 13, 4 valence electrons for group 4, 5, 6, 7, and 8. And when you get 8, you end up with what's called a complete shell. Yo, 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 Zenon, what's going on? And you end up with a complete octet rule. Now, let me show you guys some tips and tricks to help you understand how simple this can be. Okay, all the elements that are in groups 1 and 2 and 3, they tend to have a positive charge, which means they can give away the valence electrons. Those elements, with the exceptions of carbon, okay, and I'm gonna put a star by carbon, and silicon, pretty much all of those right there, even though they are in group 14, they have a positive 4 charge, but that means they have the ability to have 4 bonds, okay? So group 14, 15, 16, 17, they all have the ability to have up to 8, okay? Like to receive up to that amount, to make them have the complete 8 that the last group has in terms of being a full energy level. Or also in this case, having a full octet completion of their dots. Now, here's something else I want you guys to keep in mind, okay? All the elements, and I'm gonna put this in a different color, all the elements that are in group 14, because they have a +4 charge, that means they can receive up to 4 valence electrons. And let me get rid of these little check marks so you all can see something else. I'm all about the patterns. And let me tell you what I mean by the patterns. It's like this. Whenever you guys are looking at your elements and you're trying to figure out how many more valence electrons it can receive, go by the charge, the ionic charge also, okay? Go by the charge. So in group 14, they have the ability to receive 4 valence electrons because of the +4 charge. Now, when you get to group 15, the charge on all those elements is -3. But guess what that means? They can also receive up to 3 more, because what's 5 plus 3? That's 8. And I'm putting a little star by group 14 because although they have a +4 charge, they have the ability to receive 4 extra. Group 16 has a -2 charge. But you guys know in chemistry, because it's negative, we actually add those numbers, okay? So 6 plus 2 gives you 8. Again, their goal is to get to 8. Group 17, they all have a charge of -1. So even though I'm coming in with 7 dots, remember, I can get 1 more to give me the total 8 that I need. This is the background reminder that I want to make sure that my students are able to know, so that when you're trying to put this together to form the picture, you'll know that. Do foods have chemical formulas? Yes, 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 yes. Think about water, H2O. But when we say do food have chemical formulas, it's more or less the ingredients that you're looking at in terms of a formula, like sucrose for sugar, to answer your question. Yes. Now, based on all this background information, let me go ahead. Let me see, are cations positively charged? Yes, 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 yes. So those elements that have a positive charge, they are cations or cations, depending on, if you're from the South or from the North, the Midwest, the West Coast, we say it differently. But yes, positively charged means they can give away those extra electrons or valence electrons to those elements over here that are negatively charged. So when I look at -3, -2, -1. That tells me that it's going to combine with some other element from either group 1, group 2, or group 3. Or I'm sorry, group 13. Yes, so let me show you guys, because I can show you better than I can tell you. Okay, so let me go ahead and bring that up so you all can see that. I love y'all's questions. You guys are very, very smart. I mean, if your teachers don't make you feel smart, you best believe Professor TK, the chemist, is going to make you feel smart. Okay. All right, Newt D. Okay. So now carbon, as we were talking about earlier, it's in group 14, but it has 4 valence electrons. So that's where the 4 comes from. So 1 times 4 is going to give us 4 valence electrons. Hydrogen is in group 1. Yes, I do private tutoring. Oh, hey, Shane, my fellow chemist, aka chemical engineer. Yes, I do private tutoring. You can hit the link in my bio, and that will take you straight there. And then when you do hydrogen, hydrogen is in group 1, and that's 1 valence electron times 4 to give you 4. Now you're going to add them together and you're going to get a total of 8 valence electrons. Now, it's not hard to do this next part, guys, but I know when I was an undergrad, I didn't have a clue on what my professors were doing with this stuff. Okay, but we talked yesterday about why this is important. When you talk about how these bonds actually work, it's important for the human body. So if you're giving or administering certain medications, you need to know if it's going to go into your system properly. We talked about how certain elements that are fat soluble, like marijuana, okay, aka weed, okay, when it gets into your system, it stays in your system a long time because it is a fat soluble based plant. And because of that, it lingers in the body a lot longer. That's why it's hard to pass a drug test. Okay. On the other hand, if you're taking something like meth, it goes straight into your system and it comes out within like 3 days and it doesn't hang around the system to your body too long. So that's why this is important. Okay. Thank you, Alexis. And also, let me say something also too with this. When we looked at the chemical molecular structure for meth yesterday, I compared D to L. One is legal, one is illegal. And I shared with the students who were on live yesterday how it was hard for prosecutors to prosecute drug dealers at one point because they didn't know if they were looking at the molecular structure for D methamphetamines or L. Okay. No, hey, Dave. No, anyone that's taking chemistry, period, can utilize this stuff. I always align my lessons with the type of student that I'm in front of. If I'm talking to high school students, I talk about stuff that they can relate to on a high school level. If I'm dealing with my college students, most of my students are nursing students. So this is what I do. Yes. Well, I don't know. Idea diarrhea. Well, it depends on how you're saying it. Okay. Now, okay, Alexis. So yes, you can use this. Yes, you can use this. So now, what we're gonna do? We're gonna put carbon in the middle. Okay. Now, yesterday I also showed the students how if you are doing these problems, you can do what's called bookkeeping, where you can start off knowing how many you have of each. Okay, so let me show you what I mean by that. I know that carbon is going to come in with 4. 1, 2, 3, 4. And then I know I have 4 hydrogens. Okay, and this is just a way to bookkeep what you have, and then you can check them off accordingly. Okay, yes, this is college level. Yes. Okay, Daydrift. Yes, hit that link in my bio and I can help you. I can help you. So now what we're going to do, we're going to put carbon in the middle. Okay. Carbon is going to be surrounded by 4 valence electrons. That's 1, 2, 3, and 4. So now we can just cross that out because we don't need that anymore. And then I'm going to bring in each of my hydrogens. Here's the first hydrogen plus the one is contributing. Here comes the second hydrogen, plus the one is contributing. Here comes the third hydrogen, plus the one is contributing. And here is the last hydrogen, plus the one that is contributing. So we can actually cross out those that we've already used, okay? So we don't need them anymore. So I'm just going to cross those out. Now, here's the thing, though. Not quite a double bond, not quite a double bond. Each individual pair of dots, just so you know, FYI, each pair of dots is equal to a bond. So if I would have had two pairs of dots, that would give me a double bond. And if I had three pair of dots, that would give us a triple bond. So each pair represents a single bond. Now, here is the thing though. When you take the bond here, okay, I'm going to erase those dots in the middle and I'm going to replace them with the dashes, okay? So that way you can see what I mean by that. But also, if you look at how many I had a total of 8. And that 8 equals this number right here, okay? So I'm just going to redraw those lines and show you that those are the dashes, okay? No. Now, here's the thing. If I ask you to determine the shape of this formula here or of this structure, to determine the shape, all you have to do is look at how many bonds are attached to the one in the middle. So how many bonds do you see? How many bonds do you see attached to the middle? So let's count them. Yes, excuse me. Yes, Giselle, there are 4. Very good, guys. There are 4. So that's 1, 2, 3, and 4. Okay. Now, are there any non-bonding pairs of electrons? No. So if we were to look at our picture here, okay, and it would actually tell us what to look for with 4 bonds, 0 non-bonding. This tells us that we have a tetrahedral shape. So let me go ahead and show you guys what I mean by tetrahedral shape. I'm going to actually share the screen and bring up the chart so that you guys can see that, okay? Because that's important for you all to know as well. All right. So let me see here. Hold on, guys. I misplaced my holder, my phone holder. So it's a lot over here in terms of switching the screen. So I had to put that down so I can pull up the chart so you all can see that. Okay, so here we go right here. Okay. So here is the chart right here, okay? So as you guys can see, if you look at this column right here, number of bond pairs is 4. Lone pairs, 0. And this is why it's considered to be tetrahedral, okay? Tetrahedral. Now, if I would have had, let's say, 3 bonds attached and 1 non-bonding pairs of electrons, then you would say trigonal pyramidal, okay? So that's the difference whenever you're looking at this chart. Yes, Jamie. If you Google shapes of molecules or molecular geometry chart, that should give you this chart right here. But it should also appear in your chemistry book. But for those of you guys that are doing like online chemistry classes and you have an online like PowerPoint slides or online book, I would print this off, but you can find these charts anywhere. And let me tell y'all some other things, okay? But you didn't hear this from me. If I were you, if your teachers said that they would give you guys, like they let you have a cheat sheet, I would put these examples here too, just to save some time, okay? That's the cheat code right there, okay? That's the cheat code right there to give some examples. Like these are the examples of what those are right there. But in order to prove that you know that this is the example, you have to also draw your pictures out. So let's go back to where we were before, where we were going to actually do the next problem, okay? So we are going to do number 3, the number 3. So let me zoom out, okay? So you guys can see that, number 3. And that was ammonia, okay? So I'm going to actually erase this board, okay? And I'm going to do ammonia, NH3, NH3. Now, then, Richard, if you're still hanging tight with me, I'm going to do the one that you asked me, which was NO2, okay? I will do that one for you next, NO2. Thank you, Sharks. Hey, Skog. Okay, excellent. Excellent. You know what, Richard? Let me let me do that one because you had asked about that one earlier. So let me do that one for you. I'm going to go ahead and do that one for you. Okay, because that brings me up to this point here. And that's a great example. Okay. I think you said NO2. I'm doing good. I'm doing good. And how are you doing? So you've got N and you've got O. Okay. N and O. You're welcome. You're welcome. Okay. NO2. Okay. With the minus charge right here. Okay. Oh, this is an excellent one. Okay. Let me tell you guys why. Because we did this yesterday. Okay, this is NO2 with a negative charge. So this is a perfect example right here that we can do. So you've got one nitrogen and then you have two oxygens. Again, if I could pull my periodic table up, I would tell you guys to look at the periodic table. And again, just to recap, you're going to see that nitrogen is in group 15, but it has 5 valence electrons. Oxygen is in group 16, but it has 6 valence electrons. Okay, you see that? So now, because we know this, okay, we're going to use those numbers for this problem. So you've got nitrogen times 5 valence electrons, okay, times 5 valence electrons. And then you've got oxygen, which has, each of them has 6 valence electrons to give you a total of 12. Now, when you count these up, you get 17 valence electrons. But now, let me tell you this, in chemistry, if we have an odd number, that tells us that we're working with what's called free radicals, and they're unstable, and we don't want free radicals in this instance right here. So therefore, we have to add an extra valence electron. Thank you, Jamie, for saying that. That is correct. You will add. Now, had that been a positive one, you would subtract. So when you get 17 plus 1, you end up with 18 valence electrons. Okay? 18 valence electrons. Now, the next thing you're going to do, again, you can do the bookkeeping, which means you can just draw them out individually. Like this, I know that nitrogen is going to come in with 5. And then I know that I have 2 oxygens and they're each coming in with 6. And again, this just kind of lets you see pre-work before you actually bring the pictures together. Okay. So, and well, Jamie, I'll come back to that question. Just remind me about hybridization. Okay. So now, if you take a look, okay, what I'm going to do is start pulling this picture together. Again, those are just the 3. Again, you don't have to do this step, but you do need to know how many dots you should have in your image so that you're able to move forward with the next part of the problem, okay? So let me go ahead and show you right now. If I were to ask you which one of these elements is going to go in the middle, you would tell me nitrogen. And why nitrogen? Because nitrogen, there's only one of them. It's like a 1-to-2 ratio. The element that tends to go or tends to have the most electronegativity tends to go in the middle. But also, as an FYI, carbon, nitrogen, and oxygen, okay, those 3 also tend to go in the middle because they're negatively charged. Now, the question was, how do you know who gets the extra one? Well, I'm going to show you, okay, because this is going to be a battle on who gets the extra one. Okay, let me show you why. And that's a very good question. Who gets the extra one? So here you go. Yes, fluorine is the most electronegative element. I mean, when we say the most electronegative, that's the one that likes to get the center of attention. Cesium is the least one. They don't care about having all that attention. Okay. But most of your elements that are farther right on the periodic table, they tend to be placed in the middle. Now, again, we've got nitrogen and we have oxygen, okay? So nitrogen is going to go right there in the middle with 5. That's 1, 2, 3, 4, 5. Now, it really doesn't matter how you put them, but what you don't want to do, you don't want to do this, okay? You don't want to say 1, 2, 3 like that. You don't want to put 3 like that, okay? They always come as either a pair or solo, okay? A pair or solo, but never 3 together like that, okay? Never 3 like that. Now, just FYI. Okay, so now I've got my 5 right here, okay, on nitrogen. So now we're going to go ahead and pull in oxygen. And oxygen is going to come in with 6. I'm going to start here at the very top. That's 2, 4, and 6. And then my next oxygen right here, that's 2, 4, and 6. Now, someone asks, what about that extra one? You know, the one that we had to say +1 because of the formula being NO2 negative. Well, the extra one is going to go right there to nitrogen, right there at the very top. Now, let me show you all another way to do this because we're not done. Remember how I said carbon, nitrogen, oxygen, both of them, all 3 of them need 8. Like, you know, if you had to deal with elements like carbon or nitrogen or fluorine or chlorine or nitrogen or oxygen, they would need 8. But here's the thing though. Right now, around oxygen here, there are 8. Okay, I'm just trying to show you all right here. You see that's 2, 4, 6, 8. Around this oxygen right here, there are also 8. 2, 4, 6, 8. Now, in the middle, there's your nitrogen. And let me use a different color so you guys can see. Nitrogen has 2, 4, 6. Remember, nitrogen, because this element is in the middle, nitrogen also needs 8. Okay? So to make that work, you're going to have to pull 2 from either oxygen. So let me erase all this extra colors so you guys can see. Okay, let me erase all those extra colors. Okay, so remember, both of the oxygens are like, yeah, I'm straight. I don't know about you, but I'm good. Nitrogen said, well, I'm not good. I need one of y'all to give up your 2 so I can be satisfied as well. So what you're going to do, you can take from the left or the right. It doesn't matter. So I'm just going to pull from the right, okay? I erase those 2, and I'm going to simply pull them right here. Okay, y'all see what I just did, right? You never want to exceed 8. Do not go above 8. So now if I look at oxygen, I have 2, 4, 6, 8 around oxygen. Nitrogen, 2, 4, 6, 8. And then the other oxygen, 2, 4, 6, 8. So now this is your picture here. I'm going to leave that there because I'm going to redraw this to show you how we're going to replace those pairs and put them as dashes. So here's your oxygen right here. Dash. Here's your nitrogen with 2 on top. Double bond here. And then 2 right here. And again, you can put them on the top or the bottom. Those, it doesn't matter. It doesn't matter as long as you're showing that there are 8. And then in brackets, you're going to put a -1 on the outside, okay? Because that shows us that we had to add an extra charge on this formula here, on this structure. Whoops, sorry, y'all. Let me go back. Okay. So I'm gonna let this breathe for a moment before I move to the next part. Whoops. Okay. I'm trying to get this down here. Okay, hold on, y'all. There we go. Trying to move this down so I can show y'all. Are the brackets necessary? Or yes, you've got to put the brackets because the brackets will show that there was an extra electron added to this picture. Okay, there was an extra electron added to this picture. So you have to have the brackets. Yes. And Sharp, what do you mean are the signs always switched? What do you mean? Now, Jamie, when you say how to find the hybridization, like what do you mean? What do you mean by that? And now, and while you're, yes, that's correct. No, it would not be plus one. So in chemistry, so here's the thing. In chemistry, the formula was NO2 with a negative charge. Negative in chemistry means you can actually gain an electron, okay? Gain an electron. But if I put NH4 with the plus one charge, that means you can lose an electron, lose an electron. Okay, so that's the example or idea with this. Now, something else to keep in mind. Okay, excellent, excellent. Okay, and you know what, Jamie, what I will do for you, I because I know you're asking about hybridization, I'm going to write a note for that because that's going to take a little bit more detail to answer with hybridization. Okay. So I will actually do, and I wrote a note down for you. So I would write that down to help me remember that. And I can make something separate for you to address that particular concern. Most students that are taking, whether it's high school chemistry or even general chem one, and they're doing this, they wouldn't be required to like really go that far along in terms of hybridization. Yes, thank you, Giselle. That's correct. Yes, go ahead, Alexis. Yes. Yeah, oh yes, I'm gonna do another one. I'm gonna do another one. But now let me also say this too. We need to determine the shape of this, okay? Let's determine the shape of our formula right here, okay? So let's look at how many bonds we have attached. Oh, and by the way, resonance. Let me say this, resonance, okay? That means how many times can I move my double bond when it comes to oxygen and oxygen only? There are two resonance structures here. That means I can actually make this go like this, okay? I can actually put my double bond on this side now, okay? So resonance just pretty much means the ability for your double bond to be moved, okay, in a different location. So if you notice here, the double bond was on the right-hand side, and now the double bond is on the left side, okay? So therefore, this would it show us two resonance here, two resonance structures. Had I had, let's say, another oxygen here, then you could say three, okay? It would be three. So it's the ability to change the orientation of your double bond of oxygens. Now, that's correct, Jamie. That is correct. Now, how many bonds are attached to the middle element? You only focus on the middle element. Okay, so I look at nitrogen right here. Nitrogen has two bonds. You don't consider the double bond as two, okay? You consider the double bond as one bond, meaning how many elements, just think about how many different elements you have, okay? So you have two bonds attached to nitrogen. And then how many pairs of non-bonding pairs of electrons do you see? You only see one. Right, and the extra electrons, that's correct. So you see two bonds attached to nitrogen, one non-bonding pair. So keep that in mind. Keep that in mind because now we need to go back to our chart to see what 2 and 1 represent in terms of the shape, okay? So let's change our screen and go to the chart and see what we have right here. So 2 and 1. So let me get y'all closer to it. Okay, so there's 2 right here, and there's 1. So this shape would be bent, okay? This shape would be bent. And there is a difference between electron pair and molecular geometry. Okay, let me scroll back a little so y'all can see what I mean by that. If your teacher asks you the molecular geometry shape, then you would need to look at this column. If they ask you about the electron geometry shape, then you would look at this column. Sometimes they match up, sometimes they don't. FYI, okay? Because as you can see here, where it says tetrahedral, all these different shapes are not tetrahedral based upon the long number of pairs of electrons and the number of bonds. So just FYI. So earlier we had 2 and 1. So what shape is that? Even though it says angular here, okay? Some books will say bent and some will say different things, okay? So in this particular case, angular means bent, okay? Angular means bent. FYI. Some chemistry books will say angular, some will say bent, but angular is the same thing as bent. Because like water, see this right here, H2O, water? Water is also bent. If I were to tell you guys to drop water on the head of a penny, you would end up forming a bubble. Like water literally forms a bubble because it's a polar covalent bond. It has a bent structure. But if we did the same thing with, let's say, rubbing alcohol, it would not form a bubble. Matter of fact, it would evaporate. The alcohol, rubbing alcohol would evaporate. Okay. All right. So we got the request to do one more. Let's do one more. Let's do one that has, oh, and I think it was HCN. Someone had asked about that one earlier. Let me go back here. Let's see, where were we right here? So that was number 6, HCN, right here, HCN. So let's do that one, okay? Let's do HCN. Okay. All right. Okay, so HCN, same thing of what we've done before, hydrogen cyanide. Now, yes, yes. So now here's the thing I want y'all to know. If your teacher told you all to draw it out for hydrogen cyanide, I would hope that you could go from this to that in terms of writing the formula. Or if they told you to name this formula, I hope you can go from this to that. Okay. So your teachers may have you all doing multiple things just to challenge your thought process and to see if you remember. Just a little FYI. Okay. So anyway, you've got your hydrogen, you've got your carbon, and then you have your nitrogen. Now, since you have 3 different elements, you're going to literally draw the picture this way. Like you're going to literally put carbon in the middle, hydrogen's beside it on the left, nitrogen's beside it on the right. You've got one of each. Okay. Yes, Giselle, that's right. Carbon and nitrogen make cyanide. Yes. Lethal gas. Hydrogen has 1 valence electron because it is in group 1. Carbon has 4 valence electrons because it's in group 14. And nitrogen has 5 valence electrons because it's in group 15. Again, you're going to add these numbers up, and so you get 10 valence electrons. No, you cannot drink this. This is where they get, don't drink the Kool-Aid, okay? That comes from this particular statement alone. And the reason is because cyanide will lock your respiratory system down to the point where, of course, you won't be able to do nothing. It paralyzes your nervous system. The pre-work is to simply draw out each of them to show what they're going to each receive. Again, you don't have to do this. This is just something that I do to show my students, the pre-work. And again, where you put the pairs of electrons, I mean, they could look like this, or they could be one top, left, right, bottom. Same thing for nitrogen, 2, 4, and 5. Because ultimately, when you put them together, I mean, they're going to be what they're going to be. All right, Jazeel. Okay, so now let's go ahead and draw this out. Let me erase the other part of the screen right here. Okay. So now we've got, there we go. We've got carbon right there in the middle, okay? And because there's not going to be anything on the top of it or on the bottom of it, we're going to put the 2 dots on the left and the 2 dots on the right. So cross that out. We don't need that. Here comes hydrogen, okay? But again, watch this. I'm putting it here as a holding spot, okay? Just as a holding spot, so you can see why. I'm going to explain all of that. Because you can't put it right here, because you don't know. It needs to be paired up with something. So you can't put it right here, okay? That's a no-no for right now, okay? Or at all, period. Because hydrogen can only form a single bond, okay? It can only form a single bond. Now, here comes nitrogen plus the 5 is going to contribute. So I'm going to say 1. I gave it to carbon. That's 1, 2, 3, 4, 5. Now, here's the deal. Nitrogen needs 8. Carbon needs 8. We cannot add any extra to this process. Before we start moving these little dots around, let's make sure we have 10, okay? We've got 2, 4, 6, 8, 10. And because we have 10, let's go ahead and start shifting them into their proper spots. So remember, I said that they both need 8. Why? Because carbon and nitrogen are a part of those elements that can receive extra pairs of electrons to fulfill the octet rule. So now I'm going to take 2 from the top of nitrogen and bring them between carbon and nitrogen. So here they are right here. That's 2 right there. But guess what? Carbon says, I've got 8. 2, 4, 6, 8. Okay, let me show you in case you didn't see it. 2, 4, 6, 8. But nitrogen says, all right, carbon, I gave you 2 of mine to make you have 8, but now what about me? I'm still out in the cold. So carbon says, all right, let me give you 2 of mine. So I'm going to take these 2 at the top and bring them right here. And this is where you get what's called your triple bond, okay? You get a triple bond. Now, I should have put them on top so you all can see that. Okay, so let me make that a little bit better. So right here, okay, instead of squeezing it in, okay? I put it up at the top because this is where you get your triple bond. So now you still have 8 around nitrogen, 2, 4, 6, 8. And now carbon says, well, I have 8 as well. 2, 4, 6, and then the 8 over here between hydrogen and carbon. So all you have to do is redraw this picture by replacing the pairs of electrons with the dashes. And now here's your image. Excellent job, Alexis. I'm glad. So this is all repeating so you can, it's familiar to you. Yes. So now if we want to know the shape, how many bonds are attached to carbon? 2. There are 2 bonds attached to carbon. Are there any non-bonding pairs of electrons hanging on the top or the bottom? No. Okay, so but now you understand, Giselle. So there are zero non-bonding. Okay, perfect. Perfect. Okay. So there are two bonds attached to carbon, no non-bonding pairs of electrons on carbon. So let's go back to our chart to see what 2 and 0 would represent. So 2 and 0 right here represents a linear shape. It is a linear shape. Okay. All right. So we covered a lot today, guys. We covered a whole lot. Okay. So tomorrow is Thursday. And what we're going to do, we're going to get into electronegativity, where you have to determine also, is this a polar bond, non-polar bond, like polar covalent, ionic, all of that. And that's basic math. And what do I mean by basic math? That's where you're having to, again, refer to another chart. I don't think your teacher should make you memorize this particular chart. And let me show you all what I'm talking about. It may or may not be on this one. Let me see. Ooh. No, I don't have it here, but the chart is it's an electronegativity chart where you have to it's similar to the periodic table, but it's a little different. It's slightly different. Let me see, it might be on this one. Let me double check. Nope. Okay, I'll pull it up tomorrow. I'll pull it up tomorrow. Yes, Alexis, ionic is non-metal and metal, or in the order metal plus non-metal, and covalent bond is non-metal. How does your calculator have that, Giselle? I need to know about this. I'm gonna see if I can pull this picture. I don't know which one I'm gonna end up pulling if I do it this way. Let me see here. Um, okay, it has a whole periodic table. Okay. Well, and I don't know, guys, if I no, this is the wrong one. Hold on. I'm going to go to Google and just get an electronegativity chart that I can give you all right quick. Okay, so you all can see what do I mean by that? Okay, so I got one up so I can show you all right here. So for those of you guys right here, oh yes, an atomic radius. Yes, that's perfect. That's perfect. So as you guys can see right here, this is an electronegativity chart. And this chart tells you the values of different elements. And all you would have to do is subtract the number. I'll have a better one than this one because this is the numbers are a little blurry. I mean, even just on my screen, but they'll give you the electronegativity of those elements so that you're able to figure out. This is a better one. It's not color, but it's a better one. Okay. So right here. Yeah, so this is an electronegativity chart. So it'll tell you the values, and all you have to do is subtract the numbers, and that'll tell you whether or not the compound is ionic, polar covalent, or non-polar covalent, just by subtracting two numbers of the formula. Okay. So I appreciate you guys for logging on with me to do this lunchtime chemistry. We will be back on again tomorrow. Yes, Giselle, very good. We'll be back on tomorrow, same time, same place, learning chemistry with Professor TK the Chemist during her office hours. So, guys, you all take care and stay in a positive light. Don't let anyone lower your aura just because they aren't where they need to be. Okay. You guys keep your head up and don't give up. Keep pushing, keep pushing, keep pushing. Don't stop. Get it, get it. Okay. Take care, guys. Love y'all. See you tomorrow.